I have come again, the same person, the same channel. Uh, Today experiment I want to conduct. This is a two factory wind stator generator. This is a two factory wind generator, but I think there are some difference between them, two of it. They are the same capacity rating. So this is my frame. You can see my motor is already coupled. This is my case. This is the two armature I have. Though this one is a small bearing, you can see it. Why this one is a big bearing. So both of them are the same, but different city. Both of them cannot enter the same case. So I think I have thought about it before, more especially I have discussed it before. You can see this armature here is a 12 volt. Is a 12-volt armature. Why this armature here is 24 volts. Is a 24 volt. So I think I have experiments with it. The difference between uh, 12 volt and 24-volt armature. Both of them generate current when it is spin by either by mechanic or by engine or by motor, electric motor. So both of them generate, but at speed, at rate of the generating electricity is different. So this one is a 12 volt, this one is a 24 volt. I've experimented before. Like what I'm talking about is this armature here, or you can call it lotto here. You can see it. Each winding has its diode. Like this side now, this side of this winding now has its diode, separate diode. Then this side, you can see where they cover it. So it has its separate diode. So both of them is independently. So, but you see this lotto here, this armature here. It is 24 volt, which means this winding here and this winding here come together. They wind together, so it's work with single diode. So that is it. You can see the diode here. So both of them that dependent to each other. So any single fault here, the armature will not work. So I'm talking from experience. Like this armature, I have it in gasoline generator. So my generator is working properly, the speed is okay, but the voltage reduced from 220, I mean 230 volt to I think either 110 or 120 thereabout. I think either 80 or 100 thereabout, 100 voltage output. So I check if there is any bridge or nothing. So, but I check the stator. The stator winding is okay, but I said because the lotto, yeah, the armature is 24 volt. So I check the other side of the winding, it is okay. I check the other side, it is okay. Two of the winding is okay. So when I started leading, I found out that the the other side of the diode has already short circuit. The other side of the diode have already short circuit. So when I fix it back, the voltage goes to normal. So which means that even though when you remove one wire off from this 12 volt armature, this one can carry on. So which means that even though, assuming this is south, this is north, even though this south has a problem, the north can continue working, but the voltage will reduce. If this south gets problem, the north can proceed working. Then if this north load, the north side, north pole get problem, the south can continue working. So both of them will exist to give current when two of the pole is faulty. When the this diode has already short circuit, or the winding has already short circuit, or maybe cut off. Two of them, when two of the wire cut off, then there will not be any current. There will not be any current output from the generator. So, but this one is dependent. Any single error from this diode, there won't be any output. There won't be any output from the generator. There won't be any output from the generator. So that is the difference between uh, these two armature here. So even though the stator, both of them is factory winding. I haven't even rewind it. I haven't rewind it, but there is a difference. Like the power production will be different because let me check it for you to understand what I'm talking about. Okay, I put my my meter in the continuous reading. So now let me read from the capacitor. Let me read from capacitor. I see 9 ohms. Okay, let me read from the mains 10 ohms. So remember this one 9 ohms from the exciter, 10 ohms from mains. Okay, let's check this one. So let's this one, the yellow wire. Normally yellow wire is for capacitor, so they change the color code here. So let's lead from exciter. Okay, you can see 11. So remember this one give us 9 ohms, so this one gave us 11 ohms. Okay, so now remember this stator winding has a battery charger, but I find it ineffective. It's not effective to charge battery. So now let me read from the mains wind. Okay, it's fluctuating 11 12 11 12 ohms. So now without uh saying much, this one we let's see what happened. But from the result so far, this one will give more voltage than this one. So uh it shows that the winding is different. So let's test it and see which one will give a higher voltage. This one give us 9 ohms exciter, 10 ohms mains. This one give us I think 10 volt exciter, then 11 to 12 volt mains. So first of all, let me couple this one. I will use one lotto here. Maybe let me use this 24 volt lotto armature. Let me use it for the experiment. So let's see which one will give uh, more output. Remember, both of them is factory. This stator is factory winding. I haven't even tampered with it, so it is a factory winding stator. So now I have to couple. First of all, couple with I have to couple with this stator here. I will couple this one after. So let's know which one will give more voltage with the same capacitor, the same motor, the same speed. So first of all, let me couple it. Okay, okay. So make sure that this tallies with this hole. Okay. So now let me couple. Okay. Okay. Okay, so I have already coupled the gen. I've already coupled it, so it's very free. Okay, so this is the flame I will put on it. This is the flame. So I'll just connect the seat. So let me connect the generator. Let me connect it. Good. Okay, so I have coupled the generator. So let me lock it from here. So okay, now let me turn it around. Okay, so now this is the two battery here because the motor is 24 volts. So now I'm gonna run it. Let's see what is going on. So this is a 15 UF microfarad capacitor. Uh, okay, so let me connect my meter to the mains output main wire. So we check the output voltage from the generator. So I've already connected it from there. So now I'm gonna put only one capacitor, which is 20 UF. You can see 20 UF. So I'm gonna put this 20 UF to the generator. I've already connected 20 UF. So now the motor is 24 volts. So I'm running it from 24 volts. So let's measure. Okay, 209, 210. So this generator give us 29, 210 volts. 209, 210. There's a 210 volts with 20 UF microfarad capacitor. So let me connect. Let me connect this. Let me connect again. So okay, exactly 210, 211. So the coil, this coil, give us 210 volts. 210 volts. So now I'm gonna dismantle it back so that I will connect this coil, this stator. I'm gonna dismantle it. So okay, so I already dismantled the coil. So I will dismantle it to put the other stator. It gave us 100 and I mean 210 volts. 200 and sorry 200 and yeah 210 volts. 210 to 211 volts. So let me use it. So let me keep it this side. Then let me bring the other side. That one, let's start to. So then remember to align with the dots here. So now let me put the loto inside the armature. Okay, so you see both of them align. Two of them align. Okay. So when I tight it, I make sure that the armature rotate, the shaft rotate freely. So there's no clacking. Okay, so now let me couple it back. I'm gonna couple it back. Okay. So now let me couple the generator. So now let me tight here again. Okay. So now um I'm gonna connect my meter again to read the output that the generator will give. So let me slot it. Okay, so I've already connected. So now let me the yellow wire is for the capacitor. So I will put exactly the same capacitor I used to run the experiment with this one. So it is 20 uh 20 UF. So let me connect it. Okay, so I already connect it. So now I'm gonna run the system. Sorry. Okay. Okay. So do you see the difference? Do you see the difference? So this one give us 70 volts. Unbelievable. 70 volts. Okay. Yeah. I thought the same because this wire is touching here. So I've already reset it. So this wire is touching like a short circuiting. So let's run the test again. Actually. Mm, okay. So it gives us 214. So 215. So slightly different because The resistance ohms of this one is uh, I think 10, while this one is 11. 11 by resistance ohm. So this one give us slightly more voltage than this one. So you can see that is the it was just not much. So you can see the same capacitor, 20 UF capacitor. See, this give us 210, while this give us 215 volts. So almost. Let me run the mains winding resistance ohms. Let me shift it. You can see 10. Let me check this one again. Check this one again. You can see. So just almost the same thing. So but this one, like I said clearly, this one give more output volt, more than 3 to 4 volts, more than this. So both of them are the same factory wind, but not the same factory, but it is a factory wind generator. So you can see how they wind it. This coil. This is a exciter. This is a exciter. This is the mains. So it is a north south. So the one is upper one, uh, downside. So the exciter is here is a vertical, vertical. Yeah. Why uh the main wind is also vertical, but when you check it is a horizontal. So that is the difference. So the more the turns, the higher the voltage, the higher the resistance also. It is a pari passu. So you can see the difference. Both of them is not from the same factory, but they has almost the same thing with each other. The same capacitor value, 20 UF. So when I tested it first, the wire is touching here, so it short circuiting. That's why it give that 70 volt. So and I can notice some kind of sound from the generator, which show that there is a where the generator is short circuiting. So but when I remove it, when I fix it, so the voltage goes to normal, which is 215 volts. Remember, I put a capacitor. If I want the voltage to increase, then what I will do is that I will put more value. Like this capacitor has more value than this one. So let me run the experiment. So let's run this experiment once and for all. Okay. Okay. Sorry, the meter is reading from DC. So let me put it on AC. Okay, the same voltage. So now let me change this bigger capacitor. Let me remove this 20 UF. This one is 24 UF. Let me put this one 24 UF. Okay. So let's know. You see the difference. So this one is 24 UF, you go 243 volts. Why this one is 20 UF? So this one is 20 UF, this one is 24 UF microfarad capacitor. So you can see the difference. This one has a more value than the previous 20 UF. So that is to how to check generator status and the value